So now, in order to make that a little prettier, um, we are not going to work with points anymore. Points are great to work with, but they have the limitation that as soon as you change the screen resolution, their size does not change proportionally. So it's if you were to display that bigger, the text might not be as readable. The points would appear even smaller. So we're going to work instead with instances, which is not going to make things much harder. The abstraction level is going to be just fine, but we need to work with, instead of point material, with mesh material. But so let's create our instances. So we have one sphere. We have the instance node, and we should see the instances if we apply the material like this. So in that case, we should reduce their size. They are way too big. That should be alright. And I want to change this material. Right now it's a Lambert, which is affected by the lights, and I'd like to have something that is not affected by the lights. So I'm just going to go here. So we have materials that have been pre-created already, but I want to create a mesh basic, and I'm going to call that instances. I'm going to go back and assign it so that we can see the modification we do to it. Mesh basic instances, and now it's all dark because I still need to add the transform to them. So the instance transform is going to take the attributes. When I was talking about attributes in the previous tutorial that have been created by the scatter, so we have the ID here. In the instance node, it creates a few more attributes, which are instance position, instance orientation, scale, and color. And this is what this node is using. It is simply transforming the input points based on those attributes. So now, let's say we want to have a random color for each of those spheres. What we can simply plug something in here. So if I were to plug a constant by making it a vec3, we would see the value of that input. So if I want to have a random color for each point, I could use the same technique as I was using here, using an attribute ID and piping it a random. But the random, in my experience at least, is sort of unpredictable in the fragment shader. So we're going to use a very simple trick, which is just to normalize the ID. So we have IDs that go from 0 to however many points we have, in that case 1400, and I just want to make sure this value only goes to between 0 and 1. So I want to normalize the ID. I want to change the name, so I'm going to call it IDN, and I'm going to make sure this node name makes sense, and I'm going to plug that here. Now we have an error because group of undefined, because probably here I made a mistake, which is no mistake, so I just need to refresh the node, possibly. And I still need to make sure that the ID, IDN are going to be transferred here, otherwise they might not be used. So now let's go back to the material, and now I want to use the attribute IDN. IDN, I make sure it is declared here, and I want to use the node HSV to RGB. So I'm just going to put float to vec3, I want this to be the H, and now I'm going to put that into the color. And here we are. We have each sphere has a different color. And let's try and spice this up with some scale variation. So in that case, I can use the same technique as we had here, because we're gonna, the output of this of changing the scale is only gonna affect the vertex shader, not the fragment shader. So if I put that here, so we have different values, and if I put that the output of the random into each component of the vector, I'm gonna have each of the points is going to have a different scale. And that's better, but I feel the distribution is not the way I want. I feel the big points are taking as much more space than the smaller one, and I want to change that. So a good way to do it is just to use a ramp, so I can affect that. And also after the ramp, actually, I probably want to use a fit, so I can remap. So the random is going to be between 0 and 1. The ramp is also going to be between 0 and 1, even though it's going to be a slight different distribution. But I might want to have scales which are not just between 0 and 1, so it's good to remap them like this. So let's affect the ramp first. So I need to go back up to the material, and I can see the ramp is here, so I can affect it like this. You can see the points are changing size as I move this. Like this, probably right, but now the points are quite tiny, so that's where I want to use this attribute on the fit to change the size. And yeah, that's about it. So that's not something I feel happier about, and I can carry on working on the simulation of the particles based on that.